Hi third graders, how are you? Mrs. Conrad here. Welcome to my virtual science lab. Just kidding, it's my dining room. I am so excited to be here today, and this is one of my favorite labs. So when all of this started happening and I found out that we weren't going to be in school for third graders to come and see me for this lab, it broke my heart. So here I am bringing it to you, and I'm very excited about it. So I heard you've been studying natural disasters and how natural disasters change Earth's surface. So that's what we're going to be looking at today. And natural disasters can change Earth's surface by being constructive forces and building up new land, or being destructive forces and tearing down the land, or they can even be both. So I know you've already talked about landslides. So we can ask ourselves, are landslides constructive forces, destructive forces, or both? What do you think? They can actually be both, because if we're looking at the side of a hill, we have all this land here. When we have a landslide, that land moves. So now we have a space where the land was broken down. It's no longer there. So that is an example of a landslide being a destructive force. But all that land now moves somewhere else and settles, creating new land in another place. So that's how a landslide can also be a constructive force. So landslides can be both. You've also talked about earthquakes. Are earthquakes constructive forces or destructive forces, or both? They also can be both. Earthquakes can create large cracks in the ground and cause a lot of destruction. And where those cracks are, there's now missing land. So that's an example of how it can be a destructive force. But also sometimes earthquakes, the plates start to shift and push up against each other and build up. And that's actually how some mountains are created, are from earthquakes. So those mountains being created are an example of how earthquakes can also be a constructive force. So they're actually both. So today we're going to be asking ourselves the same question about volcanoes. How do volcanoes change Earth's surface? Are they constructive forces? Are they destructive forces? Or are they both? What do you think? What are your predictions? We will find out at the end of today's video. So, can I take you to go see a volcano? Can we go observe it with our own eyes and see for ourselves how volcanoes change Earth's surface? Would that be an easy field trip to do together? Probably not, even though that would be awesome, but probably not. So what do we do in science when we want to see something in nature and we can't see it for ourselves with our own eyes? We make a model. So that's what we're going to do today. We're going to make a model. And this is what you would have done if you came to the science lab to see me. But since I can't have you here with me, I'm just going to do it as a demonstration. So most of these items I already had at my house. So if your parents want to help you do this at home, if you have the materials, then that would be awesome. After this video, you can try this at home. But let's start with kind of what materials we're going to be using. So over here are some of our materials. We have vinegar. I just put a water bottle. All I did was take the cap, the lid off the water bottle. We have baking soda. So I just filled the cap with baking soda and kind of pressed it down. And then I have red food coloring, and I have a cup. And in the cup, I already poured vinegar and put a few drops of red food coloring. So this is just red colored vinegar. And then I have an eyedropper. So if you don't have an eyedropper at home, you might have like a turkey baster, or if any of your children's medicine has eyedroppers. If not, maybe you could just use some type of cup and pour. But I do have an eyedropper. And then back over here, I have my plate. And then I actually have 4 different colors of Play-Doh. And then I have a pencil and a paper towel. So we're going to go ahead and get started here. This plate is going to represent Earth's surface. It's just a flat surface. So we always want to kind of make sure we make our observations before we start. So again, we're really watching how volcanoes change Earth's surface. So we're starting out with a flat surface. So then I'm going to take my cap that has the baking soda in it and put it right in the middle. Okay, so the first thing I'm going to do is simulate a volcano erupting. So to do that, I'm just going to fill my eyedropper with my red vinegar, and I'm going to just squeeze it all in one squeeze right onto my baking soda, and there is our volcano eruption. Once it kind of stops moving, I'm now going to take my pencil and I am going to trace where the volcano, where the lava spread. Okay? Then I'm going to take my paper towel and soak that up. And what happens to lava? After it flows out of the volcano, what happens to the lava? Well, what it does is it cools and hardens and turns into land. So to model that, I'm going to use some Play-Doh, and this is our first lava flow after the lava has cooled and hardened and turned into land. So take a look at our Earth's surface now after our first lava flow. Okay, now we're just going to repeat for eruption number 2. Okay, and now we are going to trace okay, and then I'm going to absorb and now I'm going to spread a different color over our lava flow number 2. It doesn't have to be perfect, just general. Okay, so this is what Earth's surface looks like after lava flow number 2. Is Earth's surface changing? Sure is. Okay, let's do lava flow number 3. Okay, now let's trace it. And now we can soak it up. Okay, and now I'm going to use a third color to represent our third eruption, our lava cooling. To get sticky when it's wet. There we go. All right, so this is kind of what Earth's surface looks like after lava flow number 2. And our last eruption. Okay. All right, so think about how our Earth's surface was flat when we started. Now look what happened. Is this an example of volcanoes being constructive and building up land, being destructive and tearing down the land, or both? This is an example of it being a constructive force. It has built up new land. And if we kept going and going, you would just see more and more layers, and it would just get higher and higher. And that's how one way volcanoes change Earth's surface, is by building new land. So one reason I'm wearing this t-shirt today, this is a t-shirt my father-in-law brought me from Hawaii, and Hawaii islands are actually created from volcanoes. So what we just observed here can happen underwater. So volcanoes will erupt and the lava will harden and cool, and they'll erupt and harden and cool. And so eventually it just got bigger and bigger until it popped out over the surface of the water and just kept getting bigger and bigger. So the Hawaii Islands are formed from underwater volcanoes. And I have a video that I'm going to share with you. It is a mystery science video, and it is taking what we just modeled and it's showing you what that would look like in real life. So it starts off with a flat Earth surface, and then a volcano erupts, and you can see for yourself how that would look in real life. So the mystery science activity, it's just a video, but it might have some activities. You do not have to do those activities unless you want to. But then there's also a second video that I'm going to ask you to watch, also from Mystery Science, and it talks about the different ways volcanoes erupt. And I want you to look in that video to see if you can find any examples of how volcanoes might also be destructive forces, because they can actually be both. What we saw today was how they are constructive forces. The Hawaii Islands are how they're constructive forces. But in one of the videos from Mystery Science, you will see an example of how they can also be destructive forces. So thank you all for tuning in, and I hope you enjoyed the Mystery Science videos. I love them. I miss you. I wish I could have done this with you in the lab, and I hope you get a chance to try this at home with your parents. Thank you. Have a good day.